Hello, dear students. Last class I explained about the different types of materials: homogeneous materials, isotropic materials, and elastic materials. Today's class we will discuss about stress and strain. Okay, so in our daily life, we see that whenever a load is attached to a thin hanging wire, it elongates and the load moves downwards. You just imagine, okay, when you apply some load or a force on the thin hanging wire, what happened? Uh, that wire, it elongates and moves downwards. The amount by which the wire elongates depends upon the amount of the load and the nature as well as the cross-sectional area of the wire material. So this elongation mainly depends on the amount of the load and the nature of the load, and also the cross-sectional area of the wire material. And it has been experimentally found that whenever the load is applied, the cohesive force between the molecules of the hanging wire often offers resistance against the deformation, and the force of resistance increases with the deformation. So it means whenever the load is applied on the material, there are some resistance offered by the molecules of that material, material or wire. Okay, so if this force of resistance increases against the deformation. Okay, it also has been observed that the process of deformation stops when the force of resistance is equal to the external force. Means when the load is applied, the resistance offered by the material, right? So if the resistance is more than the load applied, then the deformation stops. There will not be any deformation. But sometimes what happens, the force of resistance offered by the molecules is less than the external force. So in such a case, what happens? The deformation continues until the failure takes place. So there are two possibilities. One is like deformation stops, means the force of resistance is more than the applied load. So there will not be any deformation. In other case, what happens? The force of resistance is less than the load applied. So in such cases, the deformation happens. So this force of resistance to the deformation, that is called stress. Okay, the deformation, that is called the strain. You understood the concept? So whenever the load is applied on the body, the molecules of that material, it offers some resistance to the deformation. So that resistance or force of resistance is called as stress, and suppose that force of resistance is less than the applied load, the body undergoes deformation. So that is called as strain. Okay. Now, let us introduce the concept of stress. As we know that the main problem of engineering mechanics of material is the investigation of the internal resistance of the body. That is, the nature of the forces set up within a body to balance the effect of the externally applied forces. The externally applied forces are termed as loads. So the loads are nothing, these externally applied forces are nothing but the loads. Okay, these externally applied forces may be due to any one of the reason, like it may be due to service conditions, or it may be due to environment in which the component works, or it may be through the contact with other members, or it may be due to the gravity or inertia forces. As we know that in mechanics of deformable solids, externally applied forces acts on a body and body suffers a deformation. From equilibrium point of view, this action should be opposed, or reacted by internal forces which are set up within the particles of materials due to cohesion. Okay, these internal forces give rise to a concept of stress. So therefore, let us define a stress like whenever some external system of forces acts on a body, it undergoes some deformation. As the body undergoes deformation, its molecules set up some resistance to deformation. This resistance per unit area to deformation is known as stress. Okay. Mathematically, stress may be defined as force per unit area. It is the ratio of force of resistance to unit area, sigma. Stress is it is represented by the symbol sigma. It is equal to this load by area. Sigma is equal to P by A. P is external force or load and A is cross-sectional area. So, SI unit of the stress is Newton per meter square or Pascal. 1 kilopascal is equal to 1000 Pascal, means 10 raised to 3 Pascal. 1 megapascal, 1 MPa is equal to 10 raised to 6 Pascal. 1 gigapascal, 1 GPa is equal to 10 raised to 9 Pascal. Okay. So, now let us consider a rectangular bar of some cross-sectional area like h and length. Okay. And subjected to some load or force as shown in the figure. In detail we can see like this. One body, it is subjected to some external force in newtons as shown in the figure. Let us imagine that this is the body. Let us imagine that the same rectangular bar is assumed to be cut into two halves at section xx. Okay, it is cut into two halves at section xx. Each portion of this rectangular bar is in equilibrium under the action of load P. Okay, and the internal forces acting at the section X has been shown like this. Okay, when the load is applied the body, it offers some resistance like this. Okay, in this direction. So now stress can be defined as the force intensity or force per unit area. So how we can write, that is stress is equal to load by area. So this is about stress. Next we'll see what is strain. Okay, when as I already told, strain is nothing but the deformation, right? When a body is subjected to some external force, there is some change of dimensions of the body. The ratio of change of dimension of the body to its original dimension is known as strain. Strain is a dimensionless quantity, means there is no unit for strain. Okay, because it is change in the length divided by original length. So both the units are same, it get cancelled. So there is no unit for strain. So strain, it can be defined as the change in dimension of an object under the application of external force. That is, the strain is equal to delta L divided by L. Delta L is change in the length and L is original length. So let us consider this rectangular body. Okay, length, and this is the height. Okay, when the load is applied, it offers some resistance. But what happens if this force of resistance is less than this applied force? Then obviously the material undergoes deformation. That deformation is nothing but strain. So it may take the shape like this. Okay, can see here the length is decreased and even height also. Okay, so that is the change in the length divided by original length, that is called as strain. So I think I hope all of you understood the concept of stress and strain. Okay, in short, what we can say, stress is the resistance to deformation and strain is the deformation. There are different types of stresses. See, mainly it is classified under three categories. Okay, the first one is direct stress or simple stress, and second one is indirect stress, and third one is combined stress. Under the direct stress or simple stress, we have two types: shear stress and normal stress. And again, under indirect stress, there are again two types: torsional stress and bending stress. And under normal stress, again there are two types: tensile stress and compressive stress. This we are studying now. In this unit, we are dealing about the direct stress or simple stress. In the next unit, we will see about the bending stress. Torsional stress is not there in your syllabus, and also combined stress also there. Okay, so first we will discuss about this direct stress or simple stress. So under this, I have already told the direct stress may be a normal stress or shear stress, right? So what is this normal stress? There are two types, normal stress and shear stress. First we will deal with the normal stress, then we will go to the shear stress. What is this normal stress? Normal stress is the stress which acts in direction perpendicular to the area. You can see this is the area of the body and it acts perpendicular to the area. Okay, normal stress is the stress which acts in direction perpendicular to the area. Normal stress is again further classified into tensile stress and compressive stress that we will study in the next class. And here this here in this figure can see the stress is in only one direction. It's acting on only one direction, in one direction. So it is called as uniaxial state of stress. Okay, such a state rarely exists. Therefore, we have biaxial or triaxial state of stress, where either the two mutually perpendicular, here this you can see biaxial state of stress, here two mutually perpendicular normal stresses acts. One is in this direction, x direction, and other one is in y direction, sigma 1 and sigma 2. Here sigma 1 and sigma 2. So two mutually perpendicular normal stresses acts under biaxial state of stress. In triaxial state of stress, there are three mutually perpendicular normal stresses acts as shown in the figure. Like this is sigma 1 in x direction, and sigma 2 that is in y direction, and sigma 3 that is in z direction. So the stresses are acting in three mutual perpendicular directions: sigma 1, sigma 2 and sigma 3, x, y and z direction. So this is about normal stress, and next class we will discuss about tensile stress and compressive stress. Thank you.